Today we're going to spend some time talking about some formulas that are very helpful in this section, sum and difference formulas, as you can see. In the next section we're going to talk about double and half angle formulas. When we get to class we will derive them so you can see where they came from, but for right now, here they are. Here's the sum and difference formulas. A couple things to point out here. It looks like, oh wow, these are really tough to remember. They're actually not. These are the ones that are pretty easy to remember. If you look at the cosine addition formula, you've got cosine of alpha plus beta, and in the cosine formula for both the addition and the subtraction, you've got cosine cosine, so the cosine of the first angle times the cosine of the second angle, and then minus, so notice here when it's plus for cosine, it's minus over here, and when it's minus for cosine, it's plus over here. So just trying to find some patterns. And the other pattern for the sine would be sine goes sine cosine, but the signs are the same. There's got to be a good mnemonic for that. Sine, if it's sine, then the signs are the same. Cosine, so the signs are opposite. So signs are the same for the sine function, and the tangent, just like the sine, plus plus here, minus minus here, and then the opposite. So anyway, after we use these formulas for a while, they become pretty easy to remember. I actually remember the sine and cosine ones better than I remember the tangent one. Addition and subtraction formulas, but nevertheless you will find that they're not that difficult to remember. So let's go ahead and use one to establish an identity. So in the most recent section 7.4 you were that was actually solving equation, I can't remember. It's either 7.3 or 7.4 where you were establishing identities. You were proving identities to be true. So this would be the more complicated side. If you remember how we did that, we chose the more complicated side to work on. We boxed the other side, we didn't touch it. So let's go ahead and use the addition formula for cosine and simplify this expression to see that we will get negative sine of theta. Okay, so the first thing we do is recognize that we have the cosine of the sum of two angles, pi over 2 and theta. Okay. And then we know that the cosine of the sum of two angles is the cosine of the first angle. Multiply that by the cosine of the second angle. And remember the cosine, the signs are different. So if this is plus in here, then this is going to be a minus here. And then we take the sine then of the first angle, multiply that by the sine of the second angle. Okay, so it's just using formulas. We know that the cosine of theta, so we'll simplify this even further. We know that the cosine of theta, or pi over 2, is 0, so that makes this whole term equal to 0. And then minus the sine of pi over 2 is equal to 1, so we have minus 1 sine theta. So we have minus 1 sine theta, or minus sine theta, so we just put a check, just like that. Okay, alright, let's go ahead and look at the second one. And I have to look over at my chart, so hopefully you've printed out a chart. You're looking at the tangent of the difference of two angles. Establishing an identity, we're going to box one side, not touch that side. Oh, so we actually get that formula right down here. So we'll use the formula. Notice that the tangent of one angle minus another, just like we have here, is equal to the tangent of the first angle, tangent of 2 pi, minus the tangent of the second angle. Divide that by 1 plus tangent of the first angle, 2 pi. Multiply that by the tangent of the second angle, which is theta. Now we just have to remember what is the tangent of 2 pi. Okay, well 2 pi is right there. We know that the tangent is the sine of that angle over the cosine of that angle. And we know that the sine of 2 pi is equal to 0. Cosine of 2 pi is equal to 1. So we have 0 divided by 1, which is 0. So everywhere we see a tangent of 2 pi, we're going to replace that with 0. And so all we get here, 0 times tangent, that goes away. We get 0 here, that goes away. So we have negative tangent over 1, which is negative tangent of theta. Check. Okay. So that's how you use sum and difference formulas to establish identities. And now take out this, hopefully this worksheet that you printed out. And these are actually more fun, I think. I like these a lot more than I do the establishing identity kind of problems. Might be a little bit hard to see, so I apologize. But our goal here is to find the cosine of alpha plus beta. Okay, so that's our goal. And we're going to use some of this information to find our goal. Okay, so we have the sine of alpha that says that the sine of alpha is equal to 4/5, and alpha happens to be an angle in between 0 and 2 pi. Well, just like we did way back when, we're going to build a triangle in that first quadrant because it says alpha is in that first quadrant. Let me use a different color. I don't know, I think you'd probably appreciate a different color. I would. So the sine of alpha being the opposite over the hypotenuse, we're going to give that opposite leg, we're going to put alpha right here, I should have done that to begin with. So the opposite leg to alpha has a length of 4, and the hypotenuse has a length of 5. And using the Pythagorean theorem, or just remembering the Pythagorean triple 3, 4, 5, we know that the other leg has a length of 3. Okay, so we're going to need that information because we're going to need to find the cosine of alpha, but we won't do that yet because you won't see the need for that yet, but we'll get to that. But the cosine of beta is 7/25, and beta is also in the first quadrant, so this is actually a pretty convenient problem. 7 would be the adjacent, 25, so I want to do this. I'll make it more like that. Okay, because this leg here is 7. Beta, put it there, the leg 7 will be the adjacent leg, and that's going to be shorter than the other one. So anyway, beta is this angle here. The cosine of beta is equal to the adjacent leg 7/25, hypotenuse. And if you remember, there's a 7, 24, 25 right triangle, a Pythagorean triple. And if you didn't remember that, then you would just take 625 and subtract 49, and you'd get a number, and you'd take the square root of that number, you'd get 24. That's why I don't like to try to do that. I like to remember the 7, 24, 25 Pythagorean triple. Okay, so let's go ahead and see if we can figure out what our goal is. Cosine of alpha plus beta, using our cosine addition formula, we know that the cosine of alpha plus beta is the cosine of alpha. Multiply that by the cosine of beta. And remember, cosine, the sign here inside the set of parentheses, is different than the sign on the outside. So minus the sine of the first angle, multiply that by the sine of the second angle. Okay, sorry, all pretty redundant, but you just have to be careful about what you're writing down. It's easy to make mistakes because there's a lot of similar terms and similar numbers. So cosine of alpha, that's the one we don't have. Cosine of beta, we have that, check. Sine of alpha, we have that, check. And sine of beta, we don't have that yet. So let's go over here and find so here's, when you underline what you need, you come over here and you figure out what you need. Cosine of alpha is the adjacent 3 over the hypotenuse 5. And then over here we need the sine of beta. So the sine of beta is equal to the opposite. I think I may have said opposite over here, but you know what I mean. Cosine of alpha is the adjacent leg 3 over 5. Anyway, sine of beta is the opposite leg, 24, divided by the hypotenuse, 25. And so now we have our cosine of alpha, sine of beta, and we can just replace these terms with what their values are. So cosine of alpha is 3/5. We're just going to substitute in the values for each one of these. Cosine of beta, that was given to us as 7/25, minus the sine of alpha, given as 4/5, and the sine of beta, which we had to work for a little bit, is 24/25. Okay, doesn't look like anything cancels, and I'm not seeing anything that cancels. 5 times 25 is 125, so we have 21, 3 times 7, 21 over 125, minus 4 times 24 is 96 over 125. Did I get that right? 4 times 25 would be 100, so minus 4, so yeah, 96. And I know that I have 21 minus 96 over 125. And I know that when the signs are different, I'm going to subtract. 96 minus 21 is 75. But since the 96 has the minus sign in front of it, the answer is going to be negative 75 over 125. Well, that begs to be simplified. 25 divides evenly into 75 3 times, and 25 divides evenly into 125 5 times. It usually doesn't work out that way, but nevertheless, this one did, so we're happy. We get negative 3/5, and that's it. Okay. I'll show you how to do this one, and then you'll have some practice problems to do on your own. So I'm going to try to limit the videos to under 30 minutes. So right now we're about 12 minutes in. And so we'll stop after this example, and we'll get into the double and half angle formulas in the next video. So we have the cosine of theta is equal to 1/3. Theta is in quadrant 4, so automatically when we see problems like this, we're going to just go ahead and build our triangle in the given quadrant. Theta there, we know that cosine is the adjacent leg divided by the hypotenuse, and therefore we need to figure out what y is. So we know that 1 squared plus y squared is equal to 3 squared. So 1 plus y squared equals 9, y squared equals 8, subtracting 1 from both sides. Taking the square root, we get y equals the square root of 8, which is 2 radical 2. And so 2 radical 2 is the length of this side, but the coordinates here are 1 comma negative 2, 2 radical, save that there, 2 radical 2. Okay, and so what are we trying to find? We're trying to find the exact value of sine of theta plus pi over 3. Alright, so sine, we're just going to use the addition formula for the sine of the sum of two angles. Sine of the first angle, remember, multiplied by the cosine of the second angle, pi over 3. The signs are the same outside and inside the parentheses, so plus cosine of theta, multiply that by the sine of pi over 3. Now, for whatever reason, some students don't like to remember that these are actually real numbers, sine of pi over 3 and cosine of pi over 3. So we're gonna we know those, and we're given that cosine of theta is 1/3. So the one we have to work for is the sine of theta. That's it. And then we just substitute in the values, and so we get the sine of theta is the opposite. Remember, the opposite over the hypotenuse, but the sign is negative in this quadrant. 2 radical 2 over 3. Okay, so check. We've got that. So we just replace the sine of theta with negative 2 radical 2 all over 3. We know that the cosine of pi over 3 is 1/2. Okay, let's make sure. Cosine of pi over 3, that's way up here. Cosine gets smaller as we go up. Okay, plus cosine of theta, well, we were given that that's 1/3. The sine of pi over 3, we know that that's radical 3 over 2. We have a common denominator, that's nice. Negative 2 radical 2 over 6. So I'm going to keep the denominator as 6. I'm not going to cancel these 2's because I need the denominator over here. Radical 3 over 6. And we have, let's write it like this. Radical 3 minus 2 radical 2 all over 6. And we are done.